Hi everyone, it's Sorkin. Today we have a problem when we are given a graph. So for example, let's take this example. Example 1, we are given a graph. We have a 0 node, node 0, node 1, and the node 2. And in this case, node 0 is connected to node 1, right? So node 0 is connected to itself and it's connected to node 1. And node 1 is connected also to node 0, right? And it's connected to itself and it's not connected to node 2. And node 2 is not connected to any other node. So, and also we are given an initial, which is the initial infected node. So for example, in our case, 0 and 1 are infected nodes. So, and what we need to do is we need to return node. If we need to remove node, and we need to return node that if removed, that node would minimize the spread of the malware. So in our case, for example, let's say we have 0 and 1, right? Since 0 is infected, so 1 also will be infected, right? Let's say that we are removing 0. We are removing 0 since they are connected, so the outcome would be, it doesn't matter which one we are removing. Let's say we are removing 0, right? So the only 1 is infected, and since 1 is infected, and the 1 is connected to 0, so the 0 also will be infected, so the outcome is 2. How about, let's say we have a 0, but we are removing 1. If we are removing 1, in that case, again, 0 infected, and because of the 0, 1 also will be infected. In that case, we need to, the total number of the infected nodes is equals to 2. In that case, if the multiple nodes could be removed could be removed to minimize the M initial. M initial is the number of the infected nodes, total number of the infected nodes. Then in that case, we need to return the one with the smallest index. The one with the smallest index in our case is 0, which we are returning here. Let's take this example and work on it. So let's say we have a graph with the 5 nodes, and we have a node 0, 1, 2, 3, 4. So in our case, node 0 is connected to itself, and it's connected to node 1. So it's connected to itself and to node 1, right? So the same way, node 1 is connected to itself and it's connected to 0. Node 2 is connected, it's not connected to 0 and 1, it's connected to itself, 2 and 3. So it's connected to 2 is connected to 3 and 4, right? And the 3 is connected to 2 and 4, and the 4 is connected to 2 and 3. Okay, and the initial that we are given in this case, so initially our node 0, node 1, and node 3 is infected. So what we are going to do, what would be our steps? Our first step is that we are going to go over each of our initial node. So for example, let's say take that 0, right? So what we do is we are removing 0. We are removing 0 from the initial and DFS searching to calculate the all infected nodes. So basically what we do is we are removing, and we see that if we remove 0, would that minimize that? What would be the total number of the infected nodes? So if we are removing 0, right? If we are removing 0 and we have 1 and 3, so total number of the infected nodes would be 5, right? So it would be 5 because if the 1 is infected, 0 also infected, and also if 3 is infected, since it's connected to all other nodes here, so all will be infected. So it's 5. Total number of the infected nodes, if we are removing first one, 0, is 5. So we are current number of the infected nodes. So that's the second step, right? So first we remove 0, then first we are going over our array. We are removing the node. The first node that we are removing is 0, right? So we are removing 0, and we are DFS searching to calculate all infected nodes. So all infected nodes in our case is 5. And then we are comparing that. If our current infected nodes, which is 5, if that is less than our minimum infected nodes, so we are maintaining this variable minimum infected nodes. So initially we are setting that to the, let's say, to integer maximum. If that is less than, if our current infected nodes is less than minimum infected nodes, then in that case we are setting our minimum infected nodes, we are updating that, and we are setting our best node to the current node. So which means that if we remove 0 in our case, right, if we remove 0, then in that case that would minimize the spread of the malware. So that's the first one. So how about now let's go to the second one. So let's say that we are removing 1, right? So we are removing 1, and now we have only 0 and the 3 as an initial. If the 0 is infected, so which means that the 1 is also infected because they are connected. If the 3 is infected, then 2 and the 4 is again infected, and then total number of infected nodes is equals to what? Is equals to 5 again, is equals to 5. So we are 5 is not less than our minimum infected nodes, so we are which means that we are not updating our best node. So since they have the same number of the infected nodes, 0 and 1, right? Doesn't matter which one we remove, we have 5 infected nodes. So then in that case we are still maintaining the, so we are going to return 0 because we already set that to, so our best node we have already set that to 0 because first we considered 0, right? So we are going to return 0. So now let's go to the last one. Now let's go to the last one when we are taking our initial, we are removing 3, right? And we are removing 3. Now we are DFS searching and finding the number of the infected nodes. If we are removing 3 in this case, right? So what's going to happen? So number of the infected nodes, 0 and 1, initial number of the infected nodes, it's going to be 2. So which means that the total number of the infected nodes is going to be 2 because 0 and 1 is not connected to 2, 3, and the 4, right? So current number of the infected nodes now it's equals to 2, and the 2 is less than our minimum infected nodes. Again, minimum infected nodes is 5. We have set that to 5 earlier, right, when we considered 0, and now we are setting our current infected nodes, since it's less than our minimum infected nodes, we are setting that to 2, right? So we are setting our minimum infected nodes to 2, and also we are updating our best node. In this case, the best node is 3, which we are returning here. First thing that we do here, we are initializing a variable n, which is this length of our graph. And the next one, we are sorting our initial. So why we are doing that? Because let's say that we have an initial 1, 0, 1, 4, and so on, and all of them are giving the same number, minimize the number of the infected nodes the same. So in that case, we need to return the one with the smallest value. So that's why we are sorting our initial. So in the next step, what we do, we are creating 2 variables. One is minimum infected nodes, which we are setting to infinity, to the max value of integer. And the next one is what we do, we are creating a best node, and initially we are setting that to the initial 0. So we are going, in the next step, we are going over our each node, and we are counting the number of the infected nodes without counting that node. So what's that mean? So for example, first we are starting with the 0, right? Let's say we have 3 initial infected nodes. So first we are starting with the 0. So we are starting with the 0, and we are creating one more variable, current infected nodes. It's a set, and we are checking if I is not equal to that node, so which means that we will consider every node except the 0, right? Except the node that we are currently removing. So for example, in this case, we are going to consider we are going to do DFS for 1 and the 3. So what we do is we are running DFS for node 1, and we are running the DFS for node 3. So what we do in the DFS, we are counting the number of the infected nodes. So first, we are also passing here the array of Boolean. So what we do here, we are, if the visited node, if our node is already visited, so which means that we don't have to run the DFS for that node. So we are returning right away. If that node is not visited, then we are setting that we are setting the value for that node is for true in the visited, and also we are adding that node to the list of the infected nodes. And the next step is we are going over our graph, and for that node we are checking that if it's connected to any node, so to any neighboring node, and if it's connected and if that node is not visited, so we are running DFS for that node also. So why we are doing that? Because we want to calculate all infected nodes with that is connected to that node. So once we exit that loop, once we exit this for loop, so what we have the minimum infected current infected nodes. So so we have the current infected nodes, and we are checking that if our current infected nodes is less than our minimum infected nodes. So in minimum infected nodes, initially we set that to the maximum, right, to the infinity. If it's less than, then we are updating our minimum infected nodes and we are updating our best node. And for example, in this case, let's say that we for the example that we have seen earlier, right, for 3. In case of 3, we have only 2 infected nodes. So our current infected nodes would be less than 5, which is our initial minimum infected node. So we are setting that to minimum infected nodes, we are setting that to 2, and our best node, we are setting that to 3, because 3 is the node that is removing of which would minimize the malware spread. As what's the time and space complexity of this solution? The time complexity is we are running our algorithm for each node. So for each node in the initial, for each node that is infected, and we are running through all the nodes in the graph. So we are doing that only once because we are using a visited, and we will visit every node only once. So our time complexity would be n to m. What about space complexity? Space complexity would be of n, because we are using 2 data structures here, array of Boolean visited, and we are also using the current infected nodes. In both of these cases, it would be the size of our graph, which is n, so our space complexity is of n. Java solution is identical. So first what we do, we are taking the variable, we are initializing a variable n, which is the size of our graph, and in the next step we are sorting our initial, because if we have multiple nodes with the same number of which minimize the number of the spread the same, so we need to return the one with the smallest index. So in the next step we are creating 2 variables, minimum infected nodes, which we are setting that to integer max value, and the best node, which we are setting to the 0 in our to the first node in the initial. And the next step, what we do, so we are going over our each node. So how we do that? So for example, in this case, we are taking node and we are running 2 for loops. So basically we are going to do that for each node except first node. So for example, let's say that we have 3 infected nodes, right? 1, 2, 3. So in the first step, we are removing 1, so we are running the DFS for 2 and 3. So what we do here, we are checking that if I is not equal to node, so which means that we are going to do that for every node but the first node, or 0 index. We will going to do that for every node but in the next step, right, but for the second one. So what we do is for each node, so for example in the first iteration, right, we are going to do that for every node except the first one, so we are doing that for 2 and 3. So we are running a DFS, and we are creating one more variable, which is current infected nodes, is a set, which is the current infected node. So what we do here is we are in our DFS method, right? So what we do, we are receiving 4 variables: our graph, our node, infected nodes, and the visited. Visited is an array of the Boolean with the size of our graph. So first we are checking that if we have already visited that node, which means that we should not run the DFS for that node again. So we are returning right away. If not, then in that case we are setting visited node to true, so which means that we are visiting that node now, and we are adding that to the list of the nodes, to the list of the infected nodes, to our set. And the next one is we are going over our graph and checking that if that node is connected to other node. If it's connected to other node, then also we are checking if it's not visited, then in that case we are running DFS for that nodes also. Once we exit this loop, right, this for loop for each node, by removing each node. First node by removing first node, by removing second node, and so on. We have the current infected nodes. So then we are checking that if our current infected nodes, the size of it, right? If it's less than our minimum infected nodes. If it's less than, then we are updating our minimum infected nodes and we are updating our best node. So as we have seen in the example earlier, right? So our minimum infected nodes would be 5. Our current infected nodes would be 2. So 2 is less than 5. So we are updating our minimum affected nodes to 5 and the setting best node to 3, which we are returning here. So what's the time and space complexity of this solution? The time complexity is n to m, m being that the size of the initial and the n being the size of the graph, because we are running that for every node in the initial, which means that for every infected nodes, and we are doing that. So our DFS would be, our time complexity of our DFS would be of n for each case, because we are visiting every node only once. So our total time complexity would be of n to m. How about the space complexity? Space complexity is we are using two data structures here. We are using a set and we are using visited. In both of these cases, the space complexity would be the size of our graph, which is of n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.